Okay, so I created like a little, what is it? Little review over the tests we've been through. Let me just admit this person real quick. Okay, so we went through Pearson's product, Spearman's rank. We've gone through 2 chi-square tests, test of independence and goodness of fit. So basically, and t-test. So for each test, I just wrote down like some pointers and some directions on how to use the tests with your data. So for this one, Pearson's product, we've been through this a bunch of times, a measure of the strength and direction of association that exists between 2 sets of data. So I don't know if you guys remember, but it's when we said like the correlation between these 2 variables are strong and positive. It was from that unit. That one was pretty easy. And then Spearman's rank, also in the same area, but instead of using the raw data, we would rank the values and then plug them into the calculator. Same thing, but instead of using the raw data, we are testing the correlation between the 2 ranked variables. And that's just some extra information I pulled from one of the PowerPoints. Oh, if you have any questions, ask. And if you think I'm saying anything wrong, jump in. Okay, so this is information that pertains to both Spearman's rank and Pearson's. This is the R value you get after you plug in all your values and you press enter on the calculator. I think she will ask us, if she puts it on the test, which I think she will, to explain the answer. So this would help. And then positive or negative, which you could see here. And then I wrote down like the directions in case you guys forgot. For the TI-84 calculator, if you have any other calculator, I'm sorry. But yeah, if you have a TI-84 calculator, this should hopefully help. And this is how your screen should look. Frequency list, there should be nothing there. All right, so I think that's it for the correlation coefficient tests. And then for the chi-square or the x-square test of independence, this test helps you determine whether there's an association. And then same thing, I put in the directions on the calculator. And then this is how you get degrees of freedom, but the calculator gives it to you, so I don't think you need to do it. Unless the question asks you for it, here's a formula. And then chi-squared goodness of fit test. This one, same thing, but actually no, it's not the same thing. There's you used another test, and the degrees of freedom, it's a different formula. So instead of testing for association, it's testing for if it fits a particular distribution, like for example, normal distribution, binomial distribution, etc. And then these are the steps. And then you guys know this, H sub 0, null hypothesis, H1, alternate hypothesis. If your chi-squared value is greater than the critical value and your p-value is less than your significance level, then you reject the null hypothesis and accept the alternate hypothesis, and vice versa. And then the t-test, we went over this most recently. So this is when you have 2 samples of data, but they are regarding the same thing. So I don't know if you guys remember the tulip example we went through in class, but yeah. And then same thing, these are the steps. And then one of the first questions on the study guide was about the assumptions. So the 2 assumptions that can be made are that both data sets follow a normal distribution and that they share the same variance. And then steps. And then it's very hard to see, but this mu1, this depends on the type of problem you're given. So you have to determine that. And I think, yeah, so if it's if it's two-tailed, yeah. If it's two-tailed, it's that the 2 means are not equal to each other. And if it's one-tailed, you have to determine if the first data set is greater than or the second data set is greater than the other. And then I just pulled this from the PowerPoint as well. Okay. So a lithium polymer battery manufacturer makes batteries for a phone company. They have 2 parallel production lines, and the factory manager wants to know if they are making batteries with the same capacity. A sample of batteries is taken from each production line, and the following capacities are found. What assumptions must be made if a t-test is to be used to determine if the 2 production lines are producing batteries with the same capacity? So this, like I stated before, the two assumptions. So the two assumptions would be the line A and line B both follow a normal distribution. And then the second assumption would be the variance of line A and line B are the same. Pretty basic, pretty simple. With these assumptions made, a t-test is to be used at the 5% level of significance. So state the null hypothesis. So yeah.
I put something in the chat. I just said that the two-tailed tests, like the two-tailed would be like when both of the mean or both of the x values aren't equal, and then for one-tailed it would be like
yeah, exactly.
Okay, cool.
Yeah, you're right.
All right.
Oh yeah, I have my chat open now so I can see. Okay, yeah, exactly. Yeah, what Renai said is exactly right. Same thing sets in the PowerPoint as well. Okay, and then state the null hypothesis. So the null hypothesis would be that mean of line A is the same as the mean of line B. Or you could stay, if you want to be like more like question wise, if you want to talk about the situation, you could say line A makes batteries at the same capacity as line B. That's more specific, but Ms. Sinha said she would accept either one. Okay. State the alternative hypothesis. So that would just be that the mean of line A is not the same as the mean of line B, and that they do not make batteries at the same capacity. Okay, calculate the p-value for this test. Okay, yeah, so I know that, so as you see in the two data sets that there's not the same number of values in line B as line A, and that's completely fine. She said with t-test, it's okay if they don't have the same number of same number of values. It'll still process and register and it will still come out to be a normal p-value, so don't worry about that. That's not unusual with t-tests.
I think there's something with like the t-test where like it has to be similar. I think the means or something like that to be similar. They can be similar and also exact, like the same to each other. So
yeah, exactly.
Supports that.
Yeah, exactly. So the number really doesn't matter. Just about we're focusing on the mean. So if you guys want to calculate the p-test p-value real quick. If anyone has a p-value, you could say it out loud or put it in the chat, but if not, I'll just put it in the document. Okay. So here is the p-value. And calculator, put them in L1 and L2, and then go to test number 4, data, L1, L2, make sure the frequencies have 1 in each, mu1, first one selected, and then pooled, yes, make sure for pooled it says yes, calculate, and then you should get the same value. Okay. If I'm going too fast, please let me know. Okay. State giving a reason whether the manager should accept the null hypothesis. So since the null hypothesis is smaller than, where is it? 0.05, which is a 5% level of significance, we would reject the null hypothesis. And also, I asked Ms. Sinha if she wanted us to write the actual conclusion as well, and she said she wants us to, because for some questions they might require you to, and for some they don't, so it's just safer to do both. So what she means by that is, remember on our null and alternate hypothesis, since we're rejecting the null hypothesis, she wants us to write that the mean of line A is not the same as the mean of line B, or line A does not make batteries at the same capacity as line B. She wants us to add that in that section as well.
So not just say like accepted.
Yeah, exactly. She wants us to be specific, and it's just to like be safe, you know, because like if it's marks you could have easily gotten, it would have been better to do more work than less. Okay. Okay. Oh, let me admit this person. Hey, Alan. We're just on the second question of the review.
Right.
Okay. Chocolate company sells bags containing approximately 300 chocolates. The chocolates come in red, blue, green, orange, black, and brown, and the company claims that the colors are equally distributed. The following table shows the distribution of colors of chocolates in a randomly chosen bag. A, state an appropriate test to show that choice of color is random and state the null and alternative hypothesis. Okay. So first we need to determine what kind of test we're using. And for okay, so for this test, we only see one variable taken into consideration. So that should tell you that we're working with chi-square goodness of fit, because we're trying to see if that set of values fits a certain distribution. So we would know based on it being only one variable and that it says equally distributed in the question that it has to do with chi-square goodness of fit. So I would write somewhere in the document, maybe even if it doesn't ask for it, I would do it regardless. But here, that's part of the points.
Hey Mira.
Yeah.
For the conclusion, like, could you just say that? So, like, for example, that question that we did before.
Yeah.
Just say like the manager should not accept the null hypothesis because the p-value is less than the significance.
Yes, you should actually say that. Yeah, I would rephrase the question given to you. That would be actually much better. So if I were you, I would do that on the study guide and on the test. Yeah, good point. Okay. So our null hypothesis would be that, okay, so this kind of gets confusing for me. So the way Ms. Sinha said is that the null hypothesis means you're not changing anything. That what is already there, that's what the null hypothesis is. But the alternate hypothesis is there's a change, like what's wrong. So in this case, the null hypothesis would be the choice of color of the chocolates is equally distributed because that's what they're claiming. So the alternate hypothesis would be that the choice of color of the chocolates is not equally distributed. Okay. BI. State the number of degrees of freedom of this data list. This one's a super easy question. Count how many different things in the question in the data table. 1, 2, 3, 4, 5, 6. 6 minus 1 equals 5. That should be super easy. Point. Okay. And then calculate the expected frequency of green chocolates. So since it's saying that the company claims that the colors are equally distributed, that means there's going to be an equal amount of colors for equal amount of chocolates per each color. So what you want to do is you want to add each of these values up, take that value, take the sum, and then divide that by 6, which you get 50.
You could have just done 300 divided by 6, but yeah, that works too.
Oh yeah, I didn't realize it's right there in the question. Yep. Yeah, or yeah, just look in the question because it usually gives you the total anyways. Okay, next, complete an appropriate hypothesis test at the 0.05% significance level, stating the p-value. Make a conclusion to your test. If you guys want to do it real quick. Wait, completed hypothesis test. Oh yeah, the observed values would just be these values, and then the expected values would just be 50 for each one. So that's how you would plug it in.
Sorry, we're finding the p-value, right?
Yeah.
Okay, so I got
P-value.
0.209.
Yep, that's correct. Okay, moving on. Also, it says make a conclusion to your test, which would be it should be accepted. The null hypothesis should be accepted because the p-value is greater. So we cannot reject it. We cannot reject the null hypothesis. So you also want to say your actual conclusion. The choice of color of the chocolates is not equally is equally distributed. Yeah. Even though it doesn't appear that way, that's how it is. Okay. Next. A study is performed to determine whether a person's favorite color of ice cream is influenced by their gender. The results of a survey for the study are shown below. Even though the test states, like it's stating that it's a chi-squared independence test, it's really easy to determine just from the question itself, from the problem itself, because it's saying influence. So that's like indicating that there's going to be that is dealing with correlation. So that's also another way to find out that what kind of test it is, even though you don't need to. Okay. A test is formed at a 1% significance level. State the null hypothesis. So this one, I feel like the null hypothesis for these kind of questions are a bit easier. So this one would be that a person's favorite color of ice cream is not influenced by their gender. Or another way you could state it is that a person's favorite color of ice cream is independent of their gender, which means that they don't correlate with each other.
Wait, Mira, are you?
Yeah.
Wait, I thought like that would be if it was not influenced. Wouldn't that be the alternative hypothesis? If it was not influenced by the gender.
I don't know. I asked Ms. Sinha and she said I was correct, but I think for these kind of questions, I think the null hypothesis is always that they are independent of each other.
Okay, gotcha.
And then the alternate hypothesis is that they do affect each other. So the alternate hypothesis would be that they actually do have a cause and effect relationship with each other.
All right, got you.
Yeah, I would associate null hypothesis with like negative, so you're like not influenced, if that helps.
Yeah, that helps. I think that thing you're saying is specifically for the chi-square.
Yeah. This is only for this. The other one, that's kind of different. So if you want to use like the negative null hypothesis, not influence association thing, use it with this one. Don't confuse yourself with the other goodness of fit test. Okay. Write down the number of degrees of freedom. This one, since there is chocolate, vanilla, and strawberry, you would take 3 minus 1 equals 2. Super easy. Okay, so that the expected number of males who like chocolate is 108. So basically what they're asking is they want us to basically like show them the work. So what we do is, since we know that expected frequency is n times p, we take, that's the total. First you take the total, and then you multiply that with, see it's saying males, so you would take 242 over 477, And then you would multiply that by chocolate. So 212 over 477. So let me put that on the document so you guys can see it. So yeah, and then if you put it in the calculator, you should get 107.5 bar, and then that would round up to 108. Okay.
Hey, can you explain like the expected frequency thing again? Because I was very confused on how to read the graph.
Yeah. So basically, when you have questions like these, you want to first look at the total. So in the very corner, this total is all of these added up equals 477, and both of these added up equals 477. So this is the total of the genders and the flavors of ice cream. So this is the first number you want to work with. So that's the first number you put in the equation. So then when you go further into the question, you see that it's asking for males. So you see male right here. You want to go and find males over here. So then that would be 242 out of 477 the total. So that would be the next part of your equation. And then you say, and then there's chocolate. So you want to go find chocolate, which is right there. I don't know if you guys can see my cursor, but then you find chocolate, drop down, total 212, and then you go and find that 477. So then that would be the next part of your equation. And then it would be 212 over 477. And then you multiply these three together and you should get your expected frequency. Or not, does that make a little bit more sense?
Yeah, it does. Thanks.
Okay, great. And then also, if you go back into her folder, there she did a lot of practices of the same problem over and over again. So I think looking at those would help as well. Okay, and then find the p-value. Okay, yeah. So for this, you would go to the matrix. You would go to the matrix, click edit, and then since there are 2 rows, 3 columns, you would first put 2, and then you would put 3. And then you would plug in the values as they appear. Not these values, because they're the total values. They don't pertain to your matrix. So 80, 88, 74, and then you put in 132, 41, 62. So after you put that into your matrix, you want to go to stat, test, and then you want to go down to goodness of fits, and then observed L1, expected L2, whichever columns you put them in, and then degrees of freedom 2, calculate, and then you should get the p-value of this. So I also asked Ms. Sinha about this question. She does not want this. Like Ms. Kelly, she does not want this on your test. If you do get a problem where the number is like super, super small, she wants you to write it out like this. She wants you to expand it. So keep that in mind. Okay. State with reason whether the null hypothesis should be accepted. Since the number is super, super small, that would be, the null hypothesis would be rejected because it is less than the significance value of 1%. And then you want to put the conclusion. Person's favorite flavor of ice cream is influenced by the gender, or a person's favorite flavor of ice cream is not independent of their gender. Okay. Next question. Okay, the following table contains data about the height and weight of 10 giraffes. Give an estimate of the weight of a giraffe that is 4.27 meters tall. Give your answer rounded to the nearest whole number. Do not include the unit. So from the data table, you should be able to deduce that we're using Pearson's because it's also asking, it's basically, when it says give an estimate, it's asking you to plug something into an equation. So when we plug in these values in the calculator, press enter, it gives you an equation. One sec. it gives you an equation y equals ax plus b, and it gives you the values of a and b. So what you want to do is you want to type out all those values, and then you want to plug in 4.27 where x is. So for example, that would look like this. So first I just wrote down the equation, wrote down each of the values, had 6 sig figs because I didn't want to, mess up the rounding. And then plugged in 4.27 and then put that into my calculator and then did my process of rounding. And since she didn't state that she wanted 3 sig figs, but just assume that it's 3 sig figs. So your answer wouldn't be 1,122. It would be 1,100. Yeah, it would be 1,120 because that's 3 sig figs. I think I sped through that one. If you have any questions, please ask or chat as well.
Yeah, just wait like 1 second. That way.
Yeah, sure. Yeah. I'll give it 20 more seconds.
Okay, good.
Okay, great. Since this meeting's gonna end in 10 minutes, I was gonna finish the the last question of the review, and I was planning on starting another meeting to go through the quiz on the different goodness of fit. So if you guys wanted to join that one, y'all can join that one as well, because I didn't want to run out of time. But if you guys can't join, I will post that one up to our YouTube as well, just letting y'all know. Okay. Data is collected on the time and hours people spend reading each day and the number of pages they read during that time. The results are shown on the table below. Calculate the Spearman's coefficient for the given data. Give your answer to 3 significant figures. Okay. Let's see. Okay. So I'm just gonna go through it as I usually would. If you have any questions, please stop me or put in the chat. Okay. So I'm gonna, when I rank it, I always give the rank 1 to the biggest number unless the question states otherwise or asks you to do otherwise. Okay. 5 would be 1. 4.5 would be rank 2. And then since there's 2 4s, right? So that would be 3 and 4. Add that, divide that by 2. 3.5. And then the next number would be 5. But these two share the same value. So that would be 5 and 6. Add them, divide them by 2. That would be 5.5. Okay. And then the next value is 7. And there's only 1, 3. So that would be 7. And then the next value is 8. And there's only 1, 2.5. So that would be 8. And then last 2 remaining values are 2, same value, same number. That would be 9 and 10. Add them, divide them by 2, 9.5. Okay, going on to the next column. First number, highest number, that would be 65. 1, second, 50, 3, 45. And then since there are 2 40s, that would be 4 plus 5 added, divided by 2, that would be 4.5. Next value is 6, which is 35. And then next value is 7, which is 30. Next value is 8, 25, 9, 15, and then 10 is 10. Makes it easy. And then you just plug in the ranks as they're shown. Oh God, yeah, that's a 7. You plug in the ranks as they're shown into L1, L2, and then go into line reg. And then you should get your value. Make sure that when you go into line reg, that the frequency list, it's empty, that it's blank. Because when I was doing it with Ms. Sinha, I had L2 in there and it kind of messed up the value. So make sure that area is blank. And then I'll just put in the value right there since you have 5 minutes left. Okay, that's the Spearman's coefficient. And in the question, it doesn't ask us to explain our answer, but I'm going to go ahead and do it anyways because it's better to be safe than sorry. Okay, so I said the Spearman's rank correlation coefficient showcased a moderate positive correlation between the time in hours, which were the X values, and the number of pages, which were the Y values. I'll just leave that up. So yeah, let me just say again, the next meeting I'm gonna open will be right after this one. And that's gonna be going through the goodness of fit, how we did the normal percentages, the binomial, what was it? Binomial PDF and normal CDF. I know a lot of us had trouble with that, so I was just gonna go through the answers in the process. So I will let y'all know when I start that meeting on the Slack as well. Does anyone have any questions? There's like 4 minutes left. I could answer anything if you guys want, or scroll back up.
This last part, can you just go over it like one more time? Because I was trying to do the ranks.
Yeah, of course. Okay, so basically this is Spearman's rank, tells us in the question. So I usually give my like number 1 rank to the highest number. So that just makes it easy for me, I think. So rank 1, there's only 1 5, so I would give that a 1, right? And then there's only 1 4.5, which is the next number, and I'd give that a 2. But since the next 2 values share the same number, it would be ranks 3 and ranks 4. So we have to add them and then divide them, which give us 3.5. Ergo, these 2 values. So I redid this question like 10 times or something because I kept screwing up the ranks. So I think a way it was easy for me is that I just counted each number, wrote down 1 through 10 and start them out as I was going, which helped me stay focused and stay organized. So keep going down, which is since 3 and 4 are taken, it's next 5 and 6, same process, 5 plus 6 equals 11 divided by 2 equals 5.5. And then you keep going, same thing over here. Largest value 1, second 2, and then 3 and 3. And then you have 4 and 5. Since they're the same number, add them, divide them by 2, there's your rank. And then you plug them into L1, L2, go to calc, go to line reg, and then where it says X list and Y list, make sure that you have your X values in your X list, Y values in your Y list. And when it's the third line where it says frequency list, make sure it's blank. Make sure there's nothing in there because that will mess up your values. Then you calculate and you should get your value. Yeah, and then the moderate positive correlation, the R value is positive, so you know that's a positive part. And then since it was 0.6, that's not exactly strong, but it's not exactly weak. So I would, if it's in the middle of 0 and 1, I would just go with moderate. Does that help, Darby?
Yes, thank you.
Okay, yeah, great. Any other questions? There's like 2 minutes left.
Could you go back to number 4 or the one we use Pearson's?
Yeah.
Y
Here?
Yes, that one. All right, cool. I just needed the values.